I'm going to start this segment. It's the second lesson within Unit 3 for basically graphing trig models. And we need to start by just getting the vocab down. So we talked about these four yesterday in class, but I'll go over them again. The first thing we talk about is the fact that sine functions, sine, cosine, tangent, they all have a period that they repeat. So after 2 pi, so once around the unit circle, sine and cosine repeat themselves. So that's the definition for period. For tangent, it repeats twice every 2 pi or just once every pi. So in terms of that, we also look at, in the equation, we talk about the amplitude. And if I can scroll down, there we go. We look at the amplitude as such. There we go. Sorry, I gotta get my pen ready to go. We look at this line kind of across the middle, perfectly straight line. That's kind of that midline of our graph here. So when we talk about amplitude, that amplitude is actually just this distance from here to here. So that is our amplitude. And again, like I said in class, a lot of people think that it's from the top clear to the bottom. So this graph, when you look at it, the midline is at 1, the top is at 3. We could actually look right here and call this the amplitude, right? The amplitude is just from the midline to either the peak or the valley. In this case, that happens to be a unit of, or a measure of 2. In the case of vertical shift, well, in this case, this specific example, whether this is a sine or cosine function, it has been shifted. The midline should be on the x-axis, but it's not. So we actually kind of have that vertical shift here. The VS, vertical shift. And that was a measure of 1. So the phase shift is just the trig definition of a horizontal shift or translation. So in this case, we don't know. It doesn't tell us whether this graph we're looking at is sine or cosine. But no matter what, neither of them starts at the valley on the y-axis. So either we've been pi over 2 if it was sine. Right? So here's where sine should start, is right in the middle, and then go up, back down, and back up. So we're either shifted pi over 2, or if this was cosine, we could look at this as, we actually got shifted. This peak should be at the y-axis. So our shift in that case would be a full shift pi. In terms of the graph and the equation, linking those two with these terms, to measure amplitude, if you're just given not a graph, but an equation, we actually, again in class, we discussed this, but the amplitude is the absolute value of that A term out front on either of these. I'm going to skip period for a minute. Phase shift is that horizontal shift. So in this equation, just like the other ones, the parent functions we've talked about with quadratics and cubics and square roots, it was x minus h. So in this case, our phase shift is just c. And also, like our other translations and transformations, we had vertical shift of d. So those are straightforward. The period on this is not going to be straightforward b, but if we were to plug numbers in for b, like 2, 3, or half, or fourth, what that's going to be doing is actually stretching and compressing our graph. And again, we did that in class briefly, but the idea is if I put a 2 in here, that means, essentially what that means is we have to fit 2 of these repetitions in the same period. So instead of being 2 pi in length for the period, we actually get it as pi. And so I guess the long and the short is we need to figure out that usually the period is 2 pi, but we have to divide it by that value b. If we take a second to remember and look back at transformations of the other graphs, the x squareds and things, we decided that the horizontal stretch and compress is also 1 over absolute value of b. So in this case, I suppose we could put absolute value there too, but yeah, our period ends up being the absolute value of b on the denominator like it was before. So those are the 4 options, not the 4 options, the 4 variables that we discussed, a, b, c, and d. Let's see. Before we move forward, I want to do a quick Desmos demonstration based on the coefficient b here. So we talked about how does b affect it. A, we can look at A too, but b is one that I think it's fun to watch this graph. But if I turn off our graph 2, the blue one, we see that our parent function sine x is here in red. If I turn it on with blue, all I've done was I've added this coefficient. I should call it b, but it wanted me to call it h, so I'm going to leave it h. Nonetheless, I've got this slider here, but sine of b of x. So see, what I can do here is I can say, if our coefficient in front of x is getting bigger, we see that the period is smaller. The amount of time it takes to repeat is getting smaller. So, but if I go from 0 to 1, all these fractions, like 1/2, 3/4, and that, what we find is as we go from 0 to 1, it does actually stretch our graph so that the period is longer. Instead of 2 pi, it's getting longer and longer. So I will, for everyone's viewing pleasure, I'm going to run this slider as an animation. So as you see, I ran that from 0 to 4. And in the range from 0 to 1, it's wider, but anywhere from 1 to 4, it's actually compressing. That is why the value is for period is 2 pi over b. The bigger the number, the longer the smaller the period. But yeah. So all right, moving on. Let's see. Tell you what, I'll make this a second video doing the examples A, B, C, and D. Oh, I just noticed we have A, and then we have B, and then somehow we get back to B again, and then C. So anyways, second video is coming up with the examples.